Welcome everyone. Today we'll discuss some of the numerical problems related to acid-base biochemistry. So let's go through some of these problems and try to solve it. Now the first question is, what are the hydrogen ion concentration, pH, hydroxide ion concentration and pOH of 0.001 molar solution of HCl. Now the first thing which should come into your mind is what kind of acid HCl is, and we all know that with the help of the Ka value, HCl has a high Ka value that suggests that it's a strong acid which ionizes completely to give H plus and Cl minus. Now what does that mean? If I am preparing an aqueous solution of HCl, it is going to ionize completely, and let's assume that the concentration of HCl is 0.001 molar. That means it's going to release this much amount of H plus, which will combine with water molecule to form hydronium ion and chloride ion. Simple. So what is the H plus ion concentration is going to be in this particular question with this much concentration given? So the amount of hydrogen ion concentration is going to be equal to concentration of the HCl which is given, which is equal to 0.001 molar. Now other way to write this number is you can write it 1 into 10 raised to the power minus 3 molar hydrogen ion concentration. So A part is, I hope this would be clear to each and every one of you. The B is the pH. So the pH of this solution is going to be negative log of hydronium ion concentration, or you can even consider hydrogen ion concentration. What that is going to be? Negative log hydronium ion concentration. Just now we have calculated. It's going to be 1 into 10 raised to the power minus 3 molar. Simple log calculation, and this value is going to be 3. You can either use a calculator or you can follow a log table. What is the C question? C part. The C says hydroxide ion concentration. Now for that, you need to just revise your ionic product of water equation, which is, if you know how to derive it, and what does it say? It says the product of, it's a product of the concentration of hydronium ion and hydroxide ion, which is equal to 1 into 10 raised to the power minus 14. This value holds true for water solution which undergoes autoionization at a temperature of around 25 degrees Celsius. Now, considering this equation, we do have the hydronium ion concentration which is coming from the HCl. We are not contributing the hydrogen ion concentration from the water, because compared to this value, the hydrogen ion concentration coming from the water ionization is going to be very, very, very low. So we'll put this value 1 into 10 raised to the power minus 3. OH minus ions I need to calculate. Kw, we all know that is 1 into 10 raised to the power minus 14. So what is the value of OH minus ions going to be? It's equal to 1 into 10 raised to the power minus 11. So I hope C part should be clear to each and every one of you. The D is the pOH. Now this is a simple thing where you need to calculate the pOH. You need to know the concentration of hydroxide ions, and that we have already calculated. So pOH is going to be negative log of hydroxide ions, which is equal to 1 into 10 raised to the power minus 11. Again, a very simple calculation. This 11 will come outside and the pOH is going to be 11. Another thing, how you can confirm whether your calculated pH and pOH values are accurate, you just add up the value of pH and pOH, and according to the ionic product of water, the pH and pOH should be equal to 14. And in this particular case, again, 3 plus 11, it is following that rule, which is going to come equal to 14. So this is all about the first question. Now we'll come back to the second question. We'll first try to read the question very carefully and then we'll try to solve it. So what has been asked in this question is the pH of a 10 raised to the power minus 8 molar solution of HCl. Now the first thing the students will do, they will read the question, and considering that they know that the HCl is a strong acid, they will directly consider the concentration of hydrogen ion equal to the concentration of HCl, which in this case is 10 raised to the power minus 8. We'll do all those simple calculations, and they will calculate the pH of the HCl solution in this particular case to be 8. But that is not true. Why? Because first of all, we all know HCl is a strong acid. So in spite of having this much dilute solution, its pH cannot go beyond 7. And we'll see what is happening in this case. So that is not a right way to do. So, but what is the proper way of solving this question? The first thing you need to understand is the contribution of H plus from HCl. So HCl is strong acid, H plus and Cl minus, and the contribution of H plus is, in this particular case, is 10 raised to the power minus 8. Fine. But at the same time, we need to consider the contribution of H plus ion from the water. Why? Because it's an aqueous solution. This solution is in water, and we all know that the autoionization of water, it's in equilibrium. The autoionization of water gives you an equation which is called as ionic product of water, which is equal to H3O plus and OH minus. This value is 1 is to 10 raised to the power minus 14. Just now we have seen at 25 degrees Celsius, if the water is pure, the concentration of H3O plus and OH minus is going to be equal. In this case, the concentration of H3O is going to be 10 raised to the power minus 7, and so is the hydroxide ion concentration, which is 10 raised to the power minus 7. So in this particular case, it's not a right idea to neglect the value or neglect the contribution of hydronium ion coming from the autoionization of water. Why? Compare these values, they are quite close. Even the H plus ion which is coming from the HCl is comparatively less. So in this particular case, we are going to consider the contribution of H plus ion both from the water as well as the HCl. So how do I need to calculate? pH is going to be negative log hydrogen ion concentration, that means 10 raised to the power minus 8 from HCl and 10 raised to the power minus 7 from water. Just a simple calculation, you need to solve it. So what is the value going to be? You can either use calculator or can follow the log table. I'm using the calculator. So if you'll add this, you'll get 1.1 into 10 raised to the power minus 7, simple. And then you can try to calculate the log value of this number, which is 1.1 into 10 raised to the power minus 7, which is going to be 6.958. There, I mean, you can only consider the values up to 2 digits, so it's approximately 6.96. But hold on, is it fine to consider this value? Now, why I'm asking you to revisit your concept, because remember, this HCl in this particular case is quite dilute. Don't you think the contribution of this H plus, which is coming from this HCl will affect the equilibrium of the autoionization? To be honest, I don't know to how much degree, but this will to some extent will affect the ionization equilibrium of water. So what should I do? Let's consider the X should be concentration of H plus coming from water. How about the concentration of H plus coming from the HCl? It's 10 raised to the power minus 8. Now, now H plus coming from HCl is 10 raised to the power minus 8. Total concentration of hydrogen ion, what is that going to be? It is going to be X plus 10 raised to the power minus 8. And how about OH minus? We all know the ionic product of water, H3O plus, it's a product of hydronium ion and hydroxide ion. So let's consider the hydroxide ion concentration is also X. Let's try to put this value into the equation of ionic product of water, which is equal to X plus 10 raised to the power minus 8, which is the concentration of hydrogen ion, and X, which is the concentration of hydroxide ion. What I need to do, I just need to put this value 10 raised to the power minus 14 x square plus 10 raised to the power minus 8x. Try to solve this equation. I can rewrite this equation as x square plus 10 raised to the power minus 8x minus 10 raised to the power minus 14x. By now, you can think that this equation is nothing but a quadratic equation, which is equal to ax square plus bx plus c, which is equal to 0. Now, what is the a here? If I have to, now I need to solve this equation in a form of quadratic equation. So you just need to do a bit more calculation, but it's good to solve in that fashion. So a is equal to 1, b equal to 10 raised to the power minus 8x. How about c? C is minus 10 raised to the power minus 14. How to solve this equation? X is equal to minus b plus minus discriminant, which is b square minus 4ac by 2a. Put these values. For example, minus 10 raised to the power minus 8 plus minus b square is going to be 10 raised to the power minus 8 square minus 4, a is equal to 1, c is equal to minus 10 raised to the power minus 14. Even though you need to do some extra bit of calculation, this is the right way, and we'll see that what are the differences we are going to be and whether those differences are significant. A again is going to be 1, so you can consider 2. Now, if you'll solve this equation, you will get so I'm just trying to continue this equation, and the value of x, so the value of x which you will get, the value of x which you are going to get is equal to 9.5125 into 10 raised to the power minus 8. You are going to get two numbers, plus and minus. Remember, the concentration is not going to be negative, so we'll neglect the negative term. So we'll go back to this part where I said that in this particular question, the total amount of hydrogen ion concentration is is coming from water, which I am considering X, as well as the 10 raised to the power minus 8 coming from this HCl. So I just need to do a bit more calculation. It's 9.5125. X is this is the X value which I have calculated using quadratic equations, and then 10 raised to the power minus 8. I've done the calculation. So what you will get is 10 raised to the power 10.5125. You can consider up to two digits into 10 raised to the power minus 8. So x is the 9.5125. Yes. So this is the value which you are going to get. So this is the total hydrogen ion concentration. Now the things are easy. I need to calculate the pH. pH is equal to negative log of 10 hydronium ion concentration or hydrogen ion concentration. So I'll just put the value here, 5125 into 10 raised to the power minus 8. Just solve it with the help of your calculator or with the help of the log table, and the value which you will get is 6.978. Now if you will say that the one where we made a simpler calculation, the value is coming to be 6.958, and here it is coming out to be 6.978. You will think that these are not much changes, but remember, in physiological systems or within the test tube where you are monitoring the things at the molecular level, even a pH change of around 0.019 will affect your experiment and will affect your data data calculation or your interpretation. So even though this value is comparatively less, the difference is comparatively less, it's sometimes these minute changes can affect the experiment, can affect the biochemical reactions. Hope these things are clear. Always try to look when we should consider the concentration of water, which is when should we consider the concentration of hydrogen ion which is coming from the water, when should we neglect it. The simple thing is that just compare the concentration of the hydrogen ion from the water with the corresponding acid. Same holds true for the base. What is the concentration of hydroxide ion from the water and the hydroxide ion coming from some bases. So this is the right way to calculate it. Hope it helps you, and take care. All the best. Do let me know if you have any further questions in the comment section. Thank you very much.